Hi, welcome to the ACM ICPC training. Today we are going to talk about this question, the castle. So for this question, it's kind of the classic flood field solution. So you are given a castle with rooms like this. Each room might have wall or have no wall on its side. So your task is to find out when you break a wall like this, and it will form the biggest room when combined. So how do we present the rooms? So we will see now. Okay, uh, 7 4, which means that the castle is in has the column of 7 boxes, and for 4 it has 4 rows. 7 times 4. You can represent it in a matrix form. Okay, let's see. What is meant by these numbers? The explanation is here. Okay, so each module tells how many 4 walls exist and is the sum of up to 4 integers. If the number is 1, means that the room has wall to the west. If it has 6, then the possible combination is as follows. 4 plus 2 equals to 6, means the room has wall to the south and wall to the east, and it at the west side and the north side of the room has no wall. So first we need to find out whether the partition, means this one, has wall or has no wall on its sides, west, north, east, south. So first we have 11. 11 is equals to 8 plus 2 plus 1, which means that on the south, the north and west has wall. But one thing you need to mention, you need to pay attention that the outer wall you cannot destroy it, which means that when you scan through the rooms, you need to consider this case. So that's all for the input, and now we will go to the solution part. First, we will iterate through every single possible rooms and give them an ID to mark the room where it belongs to. At here, let's go to this room belongs to room 0, 0, 0. So whenever we iterate through this area, we need to check whether the side of it has another room or not. It's basically checking whether it has wall beside. For this case, it has no wall on its side. So you can go through here, 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 and continue to mark the room ID. For sure, you can store the room ID using a 2D matrix. So this. Okay, so for the next operation, we will go for the 2-1. But the problem is 2-1 is already checked. So you need to keep a flag, something like this, to check whether it has been traveled or not. But for my solution, I use Boolean to do that, which is this 50-50. So after I place a room ID on it, then I put it as true. So when for the next iteration, we will check whether the area has been traveled or not. If yes, then we skip. So now 3-1. Okay, this has not been checked, so we will put a new room ID to it. 1 1. For sure, you can put any room ID to it as you like. Okay, 111. And for this, checked. And for this, 2 2 2 2 2 2 2. Okay, 2 2 2 2 2 2. Okay, 6-1 checked, 7-1 checked, and 2-1 2-2 2-3 2-3 until 6-2. It has not checked. We mark a new room ID on it. 3. Okay, 6-3 has not been marked. So we put a new room ID on it and check the room beside. 4 4 4 4 4 4. So after marking the rooms, which you use the flat fill algorithm, you need to calculate the size of the for each room. With 0 0 0 0 0. What is the size of 0? The room with ID 0, the room with ID 1, ID 2, ID 3, and ID 4. So after that, you use the flat algorithm again to check whether its site has wall or not. If the area has wall on on wall beside it, then you can try to demolish the wall by summing up the size of both rooms together, just like this. Okay, you can have 0 0 0 0 1 1 1 1 combined. So basically, for this part, it is brute force, and at the end, you find the largest room possible after demolishing the wall by brute force. But the problems comes here. For this case, you remove this wall to make the largest room. Why don't you remove this? This because there's a requirement from the question states that choose ultimate wall to remove from the set of optimal walls by choosing the module furthest from the west. If ties furthest to the south, if still tie, choose M before E. Name the wall by naming the modules that borders to it on either west or south along with a direction of L and E given the location of wall with respect to the module. Which means that when you demolish a wall, you found the largest room possible, you need to keep track of which wall you demolish. Just like for this case, 0 and 4, after demolishing the wall between them, you will get the largest wall. So for this, you need to keep track. So, and for this, you need to keep track 0 and 2, 3, 3 and 3, 4, and 2, 3 and 2, 4, and finally 1, 4. So after getting the solutions, you need to sort it out, which I did it here. Okay, solutions. But for my case, I try every single possible combinations and sort them out. This is my solution class. And this is to satisfy the question. Okay, after that, you will print the solution out, something like this. The number of rooms has cursor. So for the line 1, the number of rooms the cursor has, since you know the size of each room, so you can sum them up, and the size of largest room, you can do some simple sorting to get the largest room, or just do some checker. The size of largest room is creatable by removing one wall, which means that what we did just now. We remove a wall and get the largest room creatable by removing a wall, and the single wall to remove the largest room possible, which is this. So that's what we did just now. And to make the wall checking faster, actually I did this for the maximum number it has. We check this 1 plus 2 plus 4 plus 8 equals to, okay, 12, 14, 15. So the number ranges from 0 to 15. So we'll create an array of 16, size 16 to fit the numbers, and put a boolean to calculate whether this number has wall to south or not. Like 7, 7 is 4 plus 2 plus 1, so it doesn't have wall to south. And after that, you can use this flag to speed up your wall checking. So for this solution, okay, and yes, this solution is correct, 0.18. And this is all for this question.